There are many ways to check to see if your samples are normal. One way is to create a histogram of each sample in your data. So in this case, I want to create two histograms. One of the height values of the female turtles and another of the height values of the male turtles. To do this, I am going to use the function HIST, which represents histogram. I will then identify the data frame we are working with, and then the column, which is height. I will then subset this column, so that way we'll plot the histogram of all the height values where the gender column is female. Note here I'm going to make sure that my column names match the names of my columns in my data frame, which in this case are capitalized, so my column names will be capitalized as well. To run this code, you simply push the run button. Notice we have an error, an unexpected equal sign. This is because I inadvertently put only one equal sign in my code. To subset data, you will need two equal signs, like this. Now notice over here, we now have a histogram. This histogram, to me, looks fairly normally distributed. Now I will create an additional histogram, this time where the gender is male. I will run that code now. This code also looks a little bit more skewed than the female, but could possibly still roughly approximating a normal distribution. Another way to test for normality is to use QQ plots. To do this, we will run two lines of code for each sample. The first line of code uses this function called QQnorm. I am going to use the same code I used for my histogram. I will push run. Notice here I get a plot with a series of dots, roughly in the form of a line. I can then use a second function called QQLine to draw a line on that plot. A QQ plot takes your data and plots it against what your data would look like if it came from a normal distribution. If your data roughly approximates a normal distribution, the dots on the plot will roughly resemble a straight line. I'm going to create an additional QQ plot for the turtles that are male. I'm going to run both lines of code simultaneously. We now have two QQ plots, and we can switch back and forth between them using the arrows on the plots pane. I believe that these dots roughly resemble a straight line. This requires a little bit of human judgment and a little bit of experience. We have created a demonstration on the R tutorial website that will help you to learn what QQ plots look like when the normality assumption is violated. Another way to test for normality is to use a Shapiro-Wilk significance test. To do this, you simply use the function Shapiro.test, open parentheses, and again I am going to use the same subset that I used before. I will run the code by pushing run. And down here in the console window this time, we have the results of our Shapiro-Wilk normality test. The W value is 0.997 and our P value is 0.5868. In other words, the P value of the Shapiro-Wilk normality test represents the probability that we can get data that resembles ours if we sample randomly from a normal distribution. If the probability is really low, this means it is extremely unlikely to get data that resembles ours from a normal distribution. In this case, the probability is 58%, which is pretty high. The cutoff is usually somewhere around 0.05. We can run the test again, but this time for those turtles that are male. This time the probability is 45%, which is also very high. In this way, we have concluded using three different tests that the data in each of our samples roughly approximates a normal distribution.